So again, I can't emphasize enough that there are multiple ways you can do each question. So what I'm about to do is not the only way you could do this question. If you're ever unsure that you did it correctly, send me a picture of your work so I can check it. Maybe you're not sure if you broke a math rule or what you did was allowed. Always check with me because you want to make sure that your way is okay. So in this problem, again, the first strategy most people do is change everything into sines and cosines. So I would take the tangent and change it into sine of x over cosine of x. Notice that down here, this 1 plus sine x, it's not a Pythagorean identity for two reasons. One, it doesn't have sine squared in it, so right off the bat, you can't put it in that category. But also it's 1 plus sine. In order to be a Pythagorean identity, it would have to be 1 minus sine squared. So just pointing that out. So then from here, you're kind of stuck. So the next thing you would do is add the two fractions together. And the way you add two fractions together is you get a common denominator. So I'm going to show this with different colors. I'm going to take that first fraction and multiply it by cosine x over cosine x. So the fraction was this, and I multiplied it by cosine x over cosine x. The second fraction would get multiplied by 1 plus sine x, top and bottom. Make sure you put that in parentheses. Okay. Actually, over here, I should put parentheses around this. So then you add the two fractions together. This fraction would become cosine squared x plus this fraction is sine x, 1 plus sine x for that numerator, and my common denominator is cosine x, 1 plus sine x. You might be saying, I did that, I showed it a little differently. That's possible, right? You could have showed this maybe in more steps, possibly less steps. Again, if you're not sure, just show it to me. So then from here, a few things that you can't do, right? You cannot cancel the 1 plus sine x's. And the reason you can't do that is because of this plus sign right here. As soon as you have addition or subtraction in the numerator, you cannot cancel anything. You cannot reduce anything. You also can't simplify these cosines, again, because of that plus sign, right? You can't do any canceling until you have all multiplication in the top and all multiplication in the bottom. We do have multiplication in the bottom. We've got cosine x times 1 plus sine x, right? That's multiplication of two things. So we don't want to distribute in the bottom because our denominator is already all multiplication. We do need to distribute in the top. So in the top, I'm going to distribute that sine x. I'm leaving the denominator the same. Again, at this point, you still can't cancel because in the numerator, I have addition, right? I don't have all multiplication yet. So you can't cancel. What can you do? And this is where you might want to pause and think for a second. And the answer is what you can do is you can put together cosine x plus sine squared x. That's a Pythagorean identity. Those two highlighted things equals 1. You don't have to explain it. You're showing your work. You don't have to prove why you did that. You don't have to explain and say off to the side that's a Pythagorean identity. You're assuming people have that knowledge to figure that out. And then now from here you can cancel. So this is an invisible parenthesis in the top. That 1 plus sine x with the top with the 1 plus sine x in the bottom can cancel, which becomes 1 over cosine x. If it was not a multiple choice question, I would probably leave my answer like that. Maybe some textbooks change it into this. It all depends on the person, the textbook that you're talking to. So I would accept either of those answers. The goal is to get down to one trig function. So either 1 over cosine x or secant of x. It's like tomatoes, you know. Some people would say, I'd rather have sines and cosines. Some people would say, I'd rather not have a fraction. So again, I would accept either one. Again, last time I'm going to say this for this problem, there are multiple ways you could have done this. I saw somebody else, they changed this cosine squared x here into one of the Pythagorean identities and then simplified it from there, and it worked out as well too. The first time I did this question, I didn't do sine x over cosine x. The first time I did it, I just went straight away and started getting a common denominator right off the first step. So I started the problem completely differently. I will say my way was worse. It was more steps. You guys knew to change the sines and cosines. You're just, that's how you're kind of trained to initially look at problems. I'm not. So sometimes you guys find the easier way than what I do, because I tend to make things more complicated. If you have any questions, let me know.